Hello, welcome to Dr. Taylor's Pedagogical Notes, and we're going to look at converting a mixed number to a fraction, or a rational number, which is what a fraction is. All right, so again, we will begin with the abstract, but this is presentation number 9 in a series, okay? At this point, if you haven't looked at the other ones, I may blast through some things that you really want to look at, okay? So if it's like, where did he get that strategy and how does that work? Then you want to go back and take a look at some of these other ones, all right? If I'm dividing a fraction, you look at fraction divided by fraction. You know, whatever it is that this strategy is not making sense to you, go back and look at that slideshow, because I didn't want to, make the slideshow redundantly long because I'm covering over and over again the things I covered in the previous slides. But I do allude to them and show the steps to some degree, okay? All right, so concrete strategy. 3 1/4. I want to convert to a fraction. Well, 3 is a 1 plus 1 plus 1, so that's 3 units together, but a 1/4 is clearly not a 1. It's not a unit, it is a part of a whole. But because it has a numerator of 1, it is a unit fraction, which is different than a unit. All right, a unit is a fraction whose denominator and numerator are the same number, right? So it's a whole piece, but only 1. A unit fraction is 1 out of however many pieces I cut the whole piece into, 1/10, 1/5, 1/8, 1,000th, okay? So I have 3 units and 1 unit fraction, okay? 1/4 plus 1/4 plus 1/4 plus 1/4 is 1. So you can see the difference. The unit fractions always add up to become a unit if I add them all up. And the units then add up to become ever-increasing values up to infinity, okay? Which is not a value, but it's a concept that it's bigger and bigger and bigger. All right, notice here we decomposed a unit into ones, and we decomposed the 1 into unit fractions that are fourths, simply because that was the fraction we had, okay? We notice it takes 4 fourths to make a whole, and that's the whole notion of the unit fractions, building a unit, okay? So I said that already, and we can look at that. And that means I can write 3 and 1/4 in that manner. Now, notice that since 3 is 3 ones and 1 is 4 1/4, I can have 4 1/4 appear 3 times. I'm sorry. It's sensing my hand even when I don't touch it. I can have 4 1/4 appear 3 times. 3 times 4 1/4, right? 3 times 1. So these are strategies we talked about in previous lessons, and look back at that. Multiplication is repeated addition, if you need to. So we can rewrite 3 as follows. And then we have the extra fourth. So that's 3 and a fourth. How many fourths is that? Take a second, count them. Press pause, come back. All right, did you count them? I'm not going to say what it was, but you should have this in your head. This is your estimation to see if the strategies we're going to use make sense, okay? All right, so now you might start with the colored squares being identified as 1/4, right? So if I wanted to use colored squares, I would just say each one of these represents a fourth. So each one of these represents a unit fraction, okay? And that unit fraction can be accumulated up to any number, okay? As long as it's made out of fourths in this case, right? All right, so there's a square and another square. You see how I'm making each square worth a fourth? All right, so I'm very concrete about that. And then what do I do with this fourth down here? Well, of course, I'm going to make it a square too. And now I'm going to ask myself, how many fourths do I have? They're all a fourth, but now how many fourths, right? Well, what would I do? I would simply count them, right? That's 4 of them. Is it okay to skip count now? You bet. Could I count them one at a time? 1, 2, 3, 4, 5, 6. Absolutely. But if I have them organized in groups of 4, can't I count that 4 3 times, or skip count 4, 8, etc.? So there's a 4, and another 4, and another 4, and a what? And a 1. There's 1 of them there. Remember, this is how many fourths I have, right? Because each one of these represents a fourth. And that's why I left that drawing up there. So it would have been better to say 4 fourths plus 4 fourths plus 4 fourths plus 1/4. That would have been a more accurate way to describe it. All right, so how many fourths do we have here? 4, 8, 12, what? 13. 13 what? 13/4. Lo and behold. Does 4 go into 13? Absolutely. How many times? And if you count it out, what's remaining? Okay, that's your check. Does it undo what you just did, right? To get back to where you started. So it's really very easy to convert, and it's really not that hard. And if you keep it simple and use some strategies that help you visualize it, put your hands on it, it'll work for you. Okay, let's look at the graphical method. Graphical method, similar, right? It's all fourths, and I'm drawing the squares, right? So now I've drawn a strip diagram with 4 ticks in it. I wrote 1/4 in them. You can just say, oh, that's a fourth, and a fourth. You don't have to write it, but I'm doing this for clarity. So how many times do I have? That's 1, but I need how many more? I need 2 more strips. Okay? I use different colors just for fun. Now that's all 3, but what's left? This is 3 and 1/4. This is another time when and is addition. It's also and is where the decimal lives. There's no other place to say and in a number except between the whole number value in the units position and whatever next word you're going to say that represents the fractional parts. So this is 3 whole units and a fourth, right? So there's my and. And then I count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 what? 13/4. And there we have it, just like before, right? Over 4. Symbolic, number line. Can I do that? Sure. Does it, we think about fractions as being hard. Well, if I make each tick a 1, yeah, then it's okay, a fourth and a fourth. I could do that. Could I make each tick a fourth, though? Yeah. But if I make each tick a 1, can I think about how many fourths build up to be a 1? If 1/4 is a unit fraction, how many fourths do I need to make a whole 1? 1/4, 2/4, 3/4, 4/4, right? So every jump is either 1 or 1/4, but that 1 is 4/4. So let's see what I chose to do. See that? Oh, there's 4/4. So I need a longer number line, don't I, if I'm going to count by 1. That's 1. I need to do that 3 times. That's 2. That's 3. Notice I extended my number line. It won't kill you. And finally, 1/4. Then I can count how many jumps I take. 4, 8, 12, 13. So you could have skip counted 1, 2, 3, whoop, and a fourth, a little bitty jump between, right? It doesn't matter as long as the strategy is understandable to you, clear, better if it's your choice of things, because then it's your ideas. Don't mimic mine. Oh, he took a 1, I can't jump by 4s. Yes, you can. If you intuitively understand what you're doing and you can explain it to others, then do it. See what you get. Turns out to be wrong, explore why. That's where learning occurs. Getting right answers teaches you nothing. Getting wrong answers teaches you everything. Abstract, do it in my head. 4/4, oh, so I say 4, 8, 12, and 1 more, 13. I just skip counted in my head. That's all we're doing. Right? We're thinking about that. Okay? And so that is the end of this tape, or this video, keeping it short. And hopefully this made sense to you. If not, go back, look at it again, look at the slideshow, press pause, back it up, rewind it, watch it again. Thank you very much, and I look forward to seeing you in the next, which is a mixed number times a fraction or a rational number. All right, thank you.